The Tully Valley of central New York is lined by two north-south running hills and is cut off to its south by a recessional moraine called the Valley Heads Moraine. This and neighboring valleys are similarly glacier-cut as those found in the saturated lower elevations to the west, the Finger Lakes. The Valley Heads Moraine is also the same geologic feature which acts as a plug for the Finger Lakes. The U-shaped Tully Valley is underlain with a limestone bedrock called the Onondaga Escarpment, with roughly 121 meters of sediments atop of it, with defined dense layers between sediments. From the Tully recessional moraine to the city of Syracuse and the nearby Lake Onondaga to the north, the bedrock dips at a general slope of 9.5 meters per kilometer. The valley is about 11 kilometers long. The sediment's distinct density layers of the valley set up the Tully Valley mudslide of 1993. A large snowpack in the March of the year, followed by a large rainfall in the following month, left a lot of water on the sediment. The coarser fluvial river origin soils of the valley slopes let the water pass, but the finer, clayey lacustrine lake origin soils of the valley bottom did not. The lacustrine sediments resisted the water until a chunk of the clay soils gave in. Cracks which formed in the years leading up to it were the weak spots, and the chunk rotated and was carried into the nearby Onondaga Creek downstream, northwards along the valley bottom. The viscous mud flowed at a speed of around 1.8 meters per second, which could be outrunable, but was thick like toothpaste when flowing. Mudslides are not the same as debris flows, which are faster and are mass movements of rocks. The mudslide flowed for almost 260 meters. There were no human casualties, mainly just property damage, as well as changes in hydrology, as a few freshwater springs were rerouted and destroyed. Ancient, once long buried clays were now exposed. The scarp was a moonscape, as the sun baked the reddish clay's surface hard. It was impenetrable, with high pH and salt content. Only about a decade later did Phragmites, an invasive species, begin to colonize it, which today engulfs the scarp. The scarp did feature some unaltered bits of sediments which still have the trees like Scotch pine and the quaking aspen that grew in them in the original soup profiles, though this is the exception. Many of the trickles and streams which run through the scarp have a grey lining caused by sulfur-producing bacteria, which also gives the place a sulfuric smell. The sulfur comes from disturbed spring water which travels through shales and picks up sulfur as it goes. Syracuse earned its nickname the Salt City as it once used and produced salt in great quantities. When the local salt springs were not enough for manufacturers, they turned to alternate salt sources. They found salt beds of halite upwards of 50 meters thick, buried deep in the valley south of the city. Water was pumped in to dissolve the salt and pumped out as a very salty brine. At some point, however, the industry left Syracuse behind. The waste products from the industry booming in Salt City, like that of soda ash production, made Lake Onondaga likely one of the most polluted lakes in the world for a time, and the salt beds used as a source of salt were left hollowed out. These cavities in the salt beds is a big part of what led to what we now call the Tully Valley mud boils. Two feeder streams, the Rattlesnake and the Rainbow Creek, feed the site, with weaker, varved, mixed sediments present. On the ground, artesian pressure builds near the moraine. This is expounded by the aftermath of the aforementioned brine mining, which had now left behind around 150 artificial caverns, some of which pancaked and collapsed, exacerbating the mud boils, increasing the chance of the pressure to escape. As pressure builds, weakness in the surface is seeked out, from which the groundwater escapes, bringing sediments with it. Mud boils is a misnomer, as the water and mud does not actually boil, at a temperature of typically just over 7 degrees Celsius. There are multiple conical mud volcanoes around which the land liquefies and periodically subsides upwards of 12 meters downwards, like ring fractures. The largest of these subsided areas is 20,000 square meters. Around the boundaries of some mud boil sites, once upright trees can be seen leaning inwards. Again, Phragmites has successfully colonized a lot of these mud boils. There are both human and environmental consequences. Roads like bridges were destabilized. The sections of the creek downstream of the mud boils became turbid, and the trout which had long depended on the creek were unable to manage, as they required the formerly clear conditions of the creek. Mud boil sediment output varies and can be as great as 32,000 kilograms a day. To prevent more mud boils, or to decrease their intensity, depressurizing wells have been installed. Sediment dams were installed to try to mitigate some of the turbidity inputs from the streams, as well as directional drilling to redirect some sections of the streams around the mud boils. Various implementations of these mitigation strategies have decreased the output of some mud boils to 450 kilograms a day. However, some depressurizing wells have become mud boils themselves too.